Okay, I'm going to show how you build models using Envelope. We've got a selection of components you can add. Each component sort of helps you hide a few equations. Before we go any farther, let me show you how you make a mass, or how the mass components are made. The mass has certain state equations. Time derivative of x is equal to the x velocity. Time derivative of y, likewise. Time derivative of the x velocity, so the acceleration, equals f over m. So this is f equals ma here along both axes. For convenience, we've got a kinetic energy defined too. And those are the state equations that give you something that behaves like a mass. Once you have something that behaves like a mass, you can model masses. I'm going to add some more parts, and we'll show you what equations each part conceals as I go along. We'll build a system that has some physical chemistry in it and some mechanics, just for variety. But we don't have any limitation here to those fields. We're really just throwing equations into graphical wrappers. Here's a gas cylinder. The equations a gas cylinder conceals right now are PV equals nRT. This slider here is a mass that can only move in one direction. Let's look at those equations. Y prime, the time derivative of y, the y velocity is 0. And its derivative, the y acceleration, is 0. So this is just to make sure that the piston stays on a line. The gas cylinder's equations are dominated by the ideal gas law, which is, this is PV equals nRT, pressure equals nRT over volume. And of course, if you want this to be a van der Waals gas, if you want to use a more exciting gas law than that, you just tuck that in here where the gas law is. We have the Pythagorean theorem for determining the length of the cylinder the gas is contained in. Volume equals area times length. Here's the temperature of the gas, which is just made to vary sinusoidally. But you can put a thermal system outside here and have a port and bring the temperature in from something else, from a heater. Let me add some springs to the system so that what we're going to do is use the force from the heating and cooling of the gas to shake stuff around. So we're integrating some physical chemistry with some mechanics, just taking advantage of the fact that we have simple equations for both. You have simple equations for what you want to do, and you'll be able to do this too. So we push play, and we can see the system run. These are fairly tight springs, but not absolutely rigid. So you can see things are being shaken around by the gas, expanding and contracting. The gas cylinder has some animated features besides just its length at each moment. The red or blue shows how hot or cold the gas is, and the transparency of the gas cylinder. Here's the gas cylinder there. Shows you how much pressure the gas is under. So a nice dark blue like that is high pressure. A transparent red like this is a hot, low pressure gas. And anything you can display as animation, you can control from your equations.